Okay, right. So let's look at this is about decision-making techniques in the short term. In the short term, and sometimes referred to as key factor analysis or key limiting factor analysis. And what we're trying to do here ultimately is to utilize best a scarce resource. So typically, you will be told a scarce resource, you can find it. You can see here that you only have 800 hours of labor, and generally, you won't have enough to fulfill your full demand of both components or both products that you're trying to make. So in this scenario here, if you think about it, you need 2 hours for each unit. So that's technically 200 hours. And you need 800 hours for here. So that's 800. So you literally need 200 plus 800. That's 1,000. You don't have 1,000. You only have, you have 200 here and you have 800 here. So in effect, what we have is a scenario where we have to think, okay, how best do we utilize that? So we say who's giving us the highest contribution for each labor hour. So let's do that. So let's quickly look here. We have here selling price 100, selling price here 200. What is the material cost? So 10 a liter, 10 times 4, so that's 40, and 10 times 6, and that's 60. And then we have labor, 8 hours at 2, and that's 16, of course. 8 times 2 is 16. 8 times 8 is 64. And so the contribution here is, of course, 10 minus the 56, and that gives you the 44. And the contribution here is 200 minus the 124, isn't it? And this gives you the 76. And so you have 76 here. So we now simply, I'll just change my pen color, simply ask, well, okay, thank you very much. 2 hours here generating 44 hours of contribution. So therefore 1 hour is generating what? So it's 44 divided by 2. How much is 1 hour of labor generating in terms of contribution? So that's 44 divided by 2, which is equal to 22. And I ask exactly the same thing here. 8 hours is generating 76. So therefore 76 divided by 8, if you like, is equal to 8 times 8, 8 times 86, 8 times 9 is 72. So that's 9.5 pounds per hour. And so therefore you can naturally see this is giving us a higher contribution per this limiting factor followed by F. So we produce L first. We are only trying to produce 100 units, so we need 200 hours. So you can make all of those. So if you have a total of 800 hours, if you've used 200, it means you have 600 hours left, right? Because it tells you only have 800 hours. And if you need 8 hours to make 1 unit of F, it means therefore that if you have 600 hours in total, but you need 8 hours to make each one, that means that you can make 600 divided by 8, which is equal to 75. So you can make 75 units of F, and that's how you deal with this, right? The question goes on to then say, well, actually, the client wants 78 Ls and 78 Fs. You have to fulfill that first. And this is not uncommon, this idea that just because you can find an optimal point doesn't mean you have to fulfill certain criteria. So let's look at that. So if I need 78 Ls and 78 Fs, I have to fulfill those. So 78 Ls require 2 hours each, and 78 Fs require 8 hours each. So let's find how many hours I'm going to end up using fulfilling those first. So 78 times 2 is 156. This is 156. And 78 times 8 is 624. 624. Add these two together, you have 780. So it means that I can fulfill these, of course I can, and then I have 20 hours left, and then I can revert to my optimal plan. My optimal plan was always to make L first, and given that I need 2 hours to make a unit of L, it means I can make 10 units of L, right? And I don't have any left. So you fulfill the 78 each, and then you can do another 10 of L. So of L, which means you can do 78 units of L and 88 units of L and 78 units of F. This question looks exactly like 93, so you can apply that in 193 yourself just to make sure you're comfortable. And I will go on and do 175 because it's a little bit different. When I say it's different, it's the same principle, but the shape of the question just looks a bit different. Okay.